So today's lesson is all about finding a determinant. Okay, determinant is of course just a number associated with a matrix and is found by doing this diagonal multiplication. So we do A times D, right, down that diagonal, and then we subtract the product down the other diagonal. Okay, that's how the people that have created the matrix, right, the authors, the inventors, if you will, of the matrix, decided to do a determinant. And it works out pretty simple, right? The math here is not very strenuous. Most people would agree. Okay, so if we're going to find the determinant of this matrix, notice these quote-unquote absolute value bars. Okay, these bars mean take the determinant. Okay, that is exactly what they're telling you to do, is to take the determinants of this matrix. Determinate of the matrix. Okay, because you'll see later a normal matrix has like brackets. Right? A normal matrix by itself has brackets. So this brackets without, I guess bars without the brackets means, or is trying to tell you to take the determinant. Okay, so all the problems we're going to see here in these examples have these type of bars on them, instructing you without using any instruction in order to take the determinant. Okay, so let's do this. We do the first diagonal, which is this way. 2 times 5 minus the second diagonal, which goes this way. 3 times 4. 2 times 5 is 10. 3 times 4 is 12. 10 minus 12 is -2. So the determinant of this matrix is -2. Okay? And that's all there is to it. We do this diagonal product and we subtract the other diagonal product. Okay, pretty simple for a 2x2 matrix, which is basically all that we're going to use here for the next couple of days. Okay, it's trickier for a 3x3, and there's lots of videos out there that can show you that. But for us, we're just dealing with a 2x2. Okay, so example 2 says, take the determinant of this matrix. So we have one diagonal, 3 times 1, minus the other diagonal, 4 times -2. So I like to make this little fishy. It helps me to remember which diagonal to multiply first. 3 times 1 is 3. 4 times -2 is -8. Right? And what does minus a minus become? That becomes an addition problem. 3 plus 8 is 11. Okay, that's all there is to finding the determinant, is doing this diagonal product minus the other diagonal product. Oh geez, what do we have here? Some roots, some radicals. So I have root 2 times root 18 minus 3 times 2. Minus 3 times 2. So do you remember how to multiply radicals? Maybe yes, maybe no, but if you don't, what you do is you multiply the numbers underneath the radical together. So 2 times 18 is 36, and that product stays underneath your radical. So can we simplify the square root of 36? Yes, we can. That's normal 6. 6 minus 6 is 0. So the determinant of this matrix is 0. Okay? All the numbers are possible, positives, negatives, including zeros. They're all in there. Okay, 3 times 4 minus 6 times 2 is 12 minus 12, which is 0. So one use that we're going to study of the determinant is to make the inverse for a matrix. Okay? You use a determinant when you're writing the inverse of a matrix. So the inverse of a matrix is a matrix that, when multiplied, gives you the identity. So this is the identity matrix for a 2 by 2. Okay, zeros on the one diagonal and ones on the other. Okay, and like it says, if the determinant does not equal 0, then the inverse exists. And this is how you do it, right? There's a formula for that. So let's take a look at, see what the formula tells us to do. Number 1, it says calculate the determinant. So 1 over whatever the determinant of this matrix was. Remember, that's A times D minus B times C, right? That's how you find the determinant. So that's what goes in here. First, we calculate the determinant, and then it looks like we have some rearranging going on. Okay. These A and B, or A and D, this diagonal, notice this diagonal switches positions. The A and the D switch positions for your inverse. And these two guys become negative, right? They don't switch positions, but they do become negative. Okay, and this is a formula. And if you want to look up where this formula comes from, be my guest. Right, go learn on your own, that's fantastic. But we're just going to use this formula in order to find or calculate the inverse matrix for each of these 3 examples here. Okay, so start with example 5. The first step in writing an inverse is figuring out what the determinant is. The determinant of 4193. So remember, we do that with our fishy, our little fishy. 4 times 3 minus 1 times 9. So 4 times 3 is 12. 12 minus 9 is 3. So that's step number 1, figuring out what the determinant is. Okay, so that's this part, check. Now we can put it over 1, right? We can put it under 1 as we write your inverse. So the next step is to actually write down the inverse. So 1 over 3. Remember, the determinant goes in the denominator of that fraction. And then let's do some rearranging of our furniture. Okay, the 4 and the 3 change places. So the 3 is in this corner and the 4 is now in that corner. And what happens with the 1 and the 9? They become negative. So negative 1 and negative 9. So then the last step is to simplify this, and you simplify by taking your 1/3 on the outside and distributing it to all the pieces of your matrix. So the 3, the negative 1, the positive 4, and the negative 9. We distribute into all the parts so that we have one matrix in the box. So let's see, this is 3/3. This is negative 1/3, negative 9/3, and positive 4/3. Okay, so you don't have to show this green step here. You can go straight to doing the simplification. Okay, I'm pretty sure that you know 3 divided by 3 is 1. Okay, we don't need to simplify anything with negative 1/3. That stays a fraction. Negative 9 over 3, divides to be negative 3. And 4/3 can't reduce at all. So this becomes your inverse matrix. Okay, so not to the negative first power, but this is how we write an inverse. Negative 1 means inverse. That is your inverse matrix. Okay, let's try again. Remember the steps. The first step is to calculate the determinant. So 2003 The determinant is 2 times 3 minus 0, which is just 6, right? 6 minus 0. I don't think we have to write 6 minus 0. You can probably figure that part out. So then your inverse matrix is 1 over 6, 1 over your determinant, times, let's do some rearranging here. The 3 and the 2 switch places, and our zeros become negative. Okay, which means nothing changes with the zeros. So then let's distribute your 1/6. 3 divided by 6 is 1/2, and then we have a 0, and then a 0. 2 divided by 6 is 1/3, right? We are reducing when we have a bigger number on bottom. Okay, let's check our last example over here. 3, nope. This is 1 times negative 3 minus 1 times negative 3 minus negative 2 times 2. So this is negative 3 minus negative 2. Negative 3 minus negative 2 is, no, it's not negative 2. What am I talking about? That's negative 4. Negative 3 minus a minus, that's a plus. So negative 3 plus 4 is positive 1. Okay, so when we write our matrix, right, when we write our inverse, that would be 1 over 1, which is just 1, and 1 times anything is 1. So in other words, we don't even have to write our fraction out there. Our fraction's not going to help us at all. So we basically have to rearrange our furniture. So we'll move the 3 and the 1, right? These guys switch positions. So negative 3 goes in the first corner and 1 goes in the last corner. And then these guys become negatives. That's a positive 2 in the top right and a negative 2 in the bottom left. So we use the determinant, 1 over the determinant, in order to find out what the matrix's inverse is. Okay? That's the reason why we study anything about the determinant, so that we can find the inverse. Okay, so hopefully that's short and sweet. You've got a better understanding of these concepts of matrices, and you have a great day. Okay, bye.